Hello, my name is Sundaresh, and here's an example of one way to optimize your agent's performance by providing relevant tools using automation. Model Context Protocol MCP servers provide tools which agents choose for task execution. You should make careful, considered decisions on how many tools to expose and how specific should those tools be. A limited number of tools with broad definitions might lead to tool identification failure and LLMs spending more time in introspection and reasoning which tool to call. At the same time, exposing many granular and specific tools leads to too many options and definitions which increase redundancy, bloat context, and increase token usage and costs. To give the agent the right tools to do its job, what if you use automation to generate specific MCP server definitions suited for the agent's role? In short, you create a toolset for an agent rather than force it to do its best with existing toolsets. For instance, consider SaaS Via, an analytics platform where applications such as SaaS Model Manager and SaaS Intelligent Decisioning publish several AI models and decision flows to SaaS Micro Analytics Service or MASse, a runtime execution environment. These modules are accessible through REST API endpoints and have different input-output contracts. Make use of the MASse MCP Toolmaker Python package to convert these modules to ready-made tool definitions for a fast MCP server. Follow a simple conversion process where in just a couple of steps, you discover relevant modules in your Viast server and then convert them to either an MCP server script, which can run in studio mode, standard input-output, or another script which is customized for SaaS Retrieval Agent Manager, which is an offering for developing and managing AI agents. Here's a quick look. Install the package from PyPy through a pip install or using UV. It's recommended to stand up a virtual environment so that you can test the package first. Use the Python notebook MASse MCP Toolmaker included in the GitHub repo. To get started, you need to authenticate the package with the source via environment, which you can do so through environment variables. A sample.env file is provided for this purpose. Copy and rename it as .env and set your via environment URL and access token. After importing the package, initialize a MASse module class which discovers all published decision flows and models, classifies them as such, and executes additional filters you may choose to apply further. This is used as input in the next step, which creates an MCP server script. Based on your needs, you either create a script making use of Studio Transport or a script tailor-made for Retrieval Agent Manager. Here's a test run of the Studio script in your IDE of choice, in my case, Visual Studio Code. This is a new session where even I haven't peeked at the script to understand what tools it contains. All I remember is I did something with broker risk a while ago and want to test it. I've even forgotten all the inputs. You find that the agent engages with the MCP tool to identify which tool needs to be called, uses information in the tool to frame the right arguments, and executes the same in the SaaS Via server. The user receives a consumable result. Digging a little deeper, you can trace the actual input payload and the reasoning followed by the agent to identify the right tool and pass parameters. To conclude, the MASse MCP Toolmaker package helps you bridge the gap between models and decisions in SaaS Via and AI consumers through automated, customizable, and relevant MCP servers. If you have a SaaS Via offering that contains the micro analytics service, feel free to try this out and let us know your feedback. Thank you.